Okay, here we are. So we got our angle of elevation. When you look up at something, you got our angle of depression, looking down from somewhere, and now we're into a bunch of examples. Again, some of these examples are going to feel convoluted, and that's okay, they are. Because you're going to say, well, why didn't we just do this? Why didn't he just get a tape measure? Maybe you don't have a tape measure. Why does he have a protractor? I don't know. That's okay, it doesn't matter. We're going to use some of these convoluted scenarios to solve the problems. So we have Ike. It's a terrible name. Ike is standing on the soccer field. He looks at the roof of the school with an angle of elevation of 30 degrees. How does he know that? Your iPhones can actually do this. Do you know this? Yeah, your iPhones can do this. So grab your phones. I don't know how to do this on not an iPhone because I only have an iPhone. And what you're going to do is I want you to get your compass. No. I lied. Oh, where is it? This one? Oh, I lied. It's your measurement tool. Hey, shh. Keep party in your head. Okay, so if you take a look here, you will see that this thing has a level. And as I angle my phone, I don't know why I decided to do this, but I totally decided to do this. If I'm looking straight ahead, the angle is 0. You know what, I'll go over here and I'll look that way. But as I, Ike, look up to the top of the building, I can measure and I say, oh look, it's 30 degrees. I'm looking up, 30 degrees.
Why is this 0, David?
Where is 0? 0's level.
Why is this 0?
Why is this 0?
No, this.
I don't know.
Because it's not that.
Because it's this. This is what your phone is. Your phone's not doing this. Well, maybe it is. I don't know what your phone's doing. My phone does not say that that's 0. Straight up and down is 0.
If I look up there, they say I look 0, but
I don't know. I don't know why your phone is doing what it's doing. So, what if Ike is 42 meters away from the base of the school? How tall is the school? So, let's draw the problem, shall we? For the sake of the problem, we're going to make our life a little bit easier. Ike is no longer standing on the soccer field. He is lying on the grass. He's lying on the soccer field.
So is I thought basically just the ground.
Yes. He is laying on the soccer field. If he was standing on the soccer field, would we get the height of the building?
We would get the height of the building minus his.
We would get the height of the building minus his own height. So what we need is we need Ike to lay on the grass. So here is Ike, laying on the grass. There's Ike. She looks really uncomfortable. And he is looking up. You know what? Deal with it. Ike is fine. To the top of the building.
Shouldn't he be laying on his back?
Stop. He could be laying on his back. I'm not redrawing this. You can draw Ike however you want. Draw him lying on the ground looking at the building. It would have made more sense for him to be lying on his back, now that I think about it. Okay, I'll redraw it over here. It's bothering me now that you said that. So here we go. Here's Ike. Here's my building. There's the grass. Here's my building. Here's Ike. Ike's head. Ike is lying on the grass, and his mouth is here, and his eyes are here, and he's looking backwards over his head. To the top of the building. Okay? Ike's fine. He's not dying. See, his arms are in the air. He's happy. He's like that. Okay? Here's Ike. Ike knows somehow that the angle here
Whatever you draw is like 40 degrees.
is 30 degrees. And we know this distance from the top of Ike's head to the base of the building, somehow we know that that's 42 meters. Now we want to know how tall is the building. So, how are we going to proceed? Carolyn, do you have an idea?
Yeah, I would take the, I still don't know how to pronounce it, but,
The T1?
yeah.
The tangent?
Okay.
So why are we using tangent?
Because we know the opposite,
We want to know this distance here,
and we have the adjacent.
and that's the opposite, and we're given the length on the bottom. That is the adjacent. Because where's the 90 in this triangle?
Between the opposites, like at the building.
Yeah, it's where the building meets the ground. That's supposed to be a 90-degree angle. Most buildings, it's going to be 90.
Yeah. And then,
So now you've suggested we're going to use tangent. Because we have adjacent, we want opposite. So tan of the angle that we're referencing, that angle is?
30
Tan 30.
equals x over 42.
You're calling this x over 42. So how tall is the building?
And then times 42, and then we have 42 times 1030 equals x, so 24.25.
Cool. And we're done. Why do we want to know that? Don't know. But we now know how tall the building is.
I still don't get how you know how to use like tan or something.
It all comes down to what you have. So from this angle, what do you have? And what are you looking for?
Well, we have the adjacent.
We have adjacent, and what are we looking for?
But how come we don't use the hypotenuse?
Because what are you looking for? Read the question. What does the question ask you to find? Okay, guys, please stop talking. There's Nika's asking a good question here.
How tall the school is?
We want to know how tall the school is. So which of these two sides of the triangle is the height of the school?
Oh, the opposite?
This one right here.
that's
So we got opposite. We're looking for opposite. We have adjacent. That's going to tell us which one to use. If we remember back to SOHCAHTOA, which some people are now doing in their heads, which is great, which one uses opposite and adjacent? Tangent does. So that's how we know which one to use. Shall we do another?
Yeah.
This one I won't screw up my drawing. Abby is flying at 2,500 feet. She's in an airplane. So let's draw the situation. We've got here's our airplane. The big fat plane. There's my airplane. Here's a wing. Here's the cockpit right there. Looks like a whale. And right there in the cockpit, here's Abby.
He's a pilot.
Abby's pilot. We know that the height of the plane is 2,500 feet. That's what that little apostrophe there means. And your plane will tell you this, which is good. We want to know how far away horizontally is the town of Mission if Abby sees it below her at an angle of depression of 15 degrees. So now the question is, how do we draw this triangle? Yes, Rebecca.
That's the tallest point.
Yeah.
At 2007.
Let's put, you know what? Before you go any further, I'm going to draw the town of Mission. There's the town of Mission.
This mission is like close to Abbotsford.
Yes, Mission is close to Abbotsford.
Yes, I don't know, but it's
It doesn't have, I know it doesn't have skyscrapers. But we're drawing Mission. Okay,
It's confusing because Abby is also short for Abbotsford.
it's true. Abby, the pilot, is flying to Mission north of Abbotsford. Just call things what they need to be called, and you'll be good. So, Abby is doing what? She's looking at Mission. That's supposed to be a straight line.
You want to know how to find horizontally?
We want to know the horizontal distance, and we know the angle of depression is 15 degrees. How do we draw, which angle is the angle of depression? This is where these questions are going to get real difficult, because you don't draw the triangle properly, you're going to screw this up and we're going to lose it all.
It's called like, once you look down, but the angle is going to be right at the height
What is it going to be on this side of this line, or is it going to be on this side of this line?
on this side.
Which side?
This
Top side or bottom side?
top side.
You got to remember, angle of depression is if I was looking straight ahead and then looked down. That change is going to be the angle we want. So the triangle's actually going to look like this. And this right here is the 15-degree angle.
And then we want to find out the adjacent.
This is the 90-degree angle. Where does the 2500 go?
Between the 90-degree angle and
That's her vertical height, right? And so that's this vertical piece of the triangle. And so we want to know how far away horizontally is the town of Mission. So what side are we looking for here, Carolyn?
we're looking for the adjacent side.
We're looking for this side right here. Because we want, it says how far horizontally is the town of Mission. So the temptation, do not draw what I'm about to draw, but the temptation is to do this. Well, we know the plane is 2,500 feet up, and we want the horizontal distance, so we're going to go over horizontally, and so this is the side that we're going to look for, and people will draw this triangle and say, okay, well, this angle here is 15. That is where everything goes wrong. Because is this side 2,500? Yeah, absolutely it is. It's the height above the ground from the plane. Is this the horizontal distance to Mission? Absolutely it is. But is this the angle of depression? No. If you want to draw this triangle, what do you have to do to find this angle? Ria. Oh, sorry, I thought it was a hand. I thought you had an idea. Sorry, my bad.
The angle.
Hold on. Yeah, this angle here, not the angle of depression is 15. How do I find this angle here? I was so excited, Ria. You had an answer. Your hand was up so prominently. What shape have I drawn here? If I combine the pink lines with the blue lines, what shape have I drawn? Rectangle. What's the angle on the inside the corner of rectangle? 90. So if this whole angle here is 90, if that's 90, and this piece is 15, how do I find this piece down here? It's going to be 90 minus 15. So if you want to draw, if this triangle makes you happier, all you have to do is take that additional next step and recognize this is not the angle of depression. To get this angle, though, I just do 90 minus my angle of depression, which is going to be 75 degrees. Is that pink angle in here?
You also just say the angle of depression is at the other side. If you just flipped over the triangle to the angle.
But it's not the angle of depression now. Now it's the angle of elevation.
Okay, but then we can just like 180 minus 90 minus 15.
No, Carolyn's asking good questions. You could do that, Carolyn, yes. Okay, so let's use the blue triangle. Let's solve for the horizontal distance to Mission. Carolyn set this problem up, so someone else is going to solve it. What angles? I've got the 15. What sides do I have and am looking for relative to this angle here? I heard both of them at the same time. One of you said, I'm looking for the adjacent, and the other one of you said, I have the opposite. Nice. So we're going to use tangent. Absolutely. So tan of the angle we've got is going to equal the opposite side divided by the adjacent side. So the opposite is 2,500, and the adjacent is x. So we're going to times by x, times by x, divide by 1015. It's going to cancel these guys out, it's going to cancel these guys out. So we're going to get x is equal to 2,500 over 1015.
9,330.1.
You're just very excited to answer that. 9,300 and 0.13 feet. And I ran out of space there. There we go. Comments, questions, concerns?
Are we gonna have fun with feet? I don't like feet.
We don't like feet? You have 2 of them, though.
Can we just do centimeters?
No, sometimes we're going to work with feet. Okay, are we cool? Flip the page. How many examples do I want to do here, and when should I start? You know what? I would like you guys. Maybe not. Ooh. How many do I want to do, and how many should I just free you to do? Okay, so let's talk through these things here. Okay, so there's a bunch of different questions, a bunch of different styles of questions here. I'm not going to do them all, but we're going to set some of these things up so you guys can see how they roll. So in question number 3, it says a road rises 1 meter for every 19 meters measured along the road. So what does that mean? What's that going to look like as a little triangle? Sorry? A road rises 1 meter for every 19 meters measured along the road. We're doing number 3. What does that mean? What is my road doing? It's rising. So let's draw that. And we're told that for 19 meters measured along the road, this is the road. What have we done? We went up 1 meter. So where am I going to put that 1 meter? The vertical line. That's going to be my 1 meter here. Is this to scale? Obviously not. But so then this is going to be the triangle that we're forming here. Now the question says, to the nearest meter, how far does a car travel horizontally when it travels 300 meters along the road? So now what they're doing is they're taking this and they're extending it. They said, okay, well, we know for 19 meters along the road, 1 meter has gone up. What happens if we do this? And now, this was 19 meters. How long is my road now? Now we're at 300 meters. And what do I want to find? Nope. It said, how far does a car travel horizontally when it travels? So actually what we care about now is this. I want to know what this length is here. The trouble you guys are going to have is what these drawings actually look like. But if you break down what is being said and use the parts of your brain that associate words with pictures, you can put it together and you can build something that looks like this. This is what we want. So how would we start something like this? What do we need? There's one piece of information we absolutely have to have. Kyla. That is the one piece of information we absolutely have to have. We need this angle right here. Because once we have this angle, then we can use the big triangle and that little angle and this 300 to find that guy there. So I'm going to leave that for you to finish. Okay? So we'll come back to it. Question 4. Determine the area of this rectangle to the nearest tenth of a square meter. The piece you need here is the area of a rectangle, which you would learn back in middle school. How do you find the area of a rectangle? Area of a rectangle is equal to the length times the width. So, can we use trig to find the length and width of this rectangle? We've got the distance across. We've got a 90. We've got an angle in here. Can we find the length and the width? Or you could find the area of a triangle and add them together, sure. That's half base times height. You have to do the same amount of work. Can we find the two sides we need? Okay. Then that is all of number 4. See, 4 is not so bad. 5 is the same idea. I want to find the length of mn to the nearest tenth of a centimeter. Ooh, yeah, where do we even begin? Does anyone have any ideas? Take a look at 5. What do you see? Rebecca.
You want to try and figure out the angle that is K?
What are we going to do? So let's work our way backwards. We want mn. All I have in this triangle is an angle. What do I need in this triangle to find a side length? mn.
I can get the angle for n.
Yeah, but is that useful?
No.
Okay, so let's not do that then. So to find mn, if all I'm given is an angle, is I need another side, right?
So we can get the
What Presley just suggested was, what happens if am I able to find this side right here?
we got the other triangle. We got a.
So we're going to find that side, and then we're going to use that side to find the next side. I will leave you to that. Okay, so what I'm going to do now is I'm going to free you to do a whole bunch of these problems. I have put a metric crap ton of them in here. So here's what you're going to do. First, I want you guys, I'm not going to overwhelm you with what I'm going to assign. So the first thing I'm going to set is this. I want you to do 3 to 7. Finish 3, finish 4, finish 5. And I want you to try 6 and 7 on your own. Okay, that's what I'm going to give you now. I'm going to come around, I'll float around and see how things go. If you finish that, let me know. We'll check your work, and then we can free you on to more of this. Give it a shot. What is the horizontal distance traveled by the car? Anybody? Number 3. Carolyn.
The total distance is 299.58 meters.
Can anyone confirm that that is true? 10 meet says we're good. Love it. Number 4, what is the area of the triangle? 10 meet. 53.96. And rounded to the nearest tenth, that's going to be 54.0, and the units on that are going to be meters squared. Can anyone confirm 54 meters squared? Boom, boom, boom. Love it. Question number 5. What is the length of mn to the nearest tenth of a centimeter? Kyla, I see that hand. Is it 5.2?
Yeah.
Can someone confirm 5.2 centimeters? Carolyn and Chelsea and Shyla all say you're right. So we must be. I like it when people who aren't working in the same group all agree. We're good. Number 6, Gavin. What are the heights of those trees? 19 and 15 for the right one. And we have confirmation from 10 meet and from Carolyn and from Acom. Love it. And the last one, what is the angle, Rebecca, GHJ, to the nearest tenth of a degree? 60.7 degrees. Angle GHJ equals 60.7 degrees. And we have confirmation from some people on that. Love it. If you struggle with any part of those, please do ask. I am going to be giving you a trig quiz tomorrow that covers all of trig. It'll be great. It's like your final test for trig, but trig has been such a small unit. I mean, if you guys do really well on it, I could just call it your trig test. And then it'll be weighted just like your other tests, and it'll make you better. Marcus call it a quiz, and then it's not worth very much, and I'll just put all the trig onto the final. So we'll see how it goes.
All the rest is just like we get.
So it's everything we've done on trig. If you tell me what the sine of an angle is, you tell me what the measurement of an angle is given. I'm gonna give it to you tomorrow. Yes. Everything you've got left is just more word problems. So if you take a look here, this one's a really gnarly one here. All of the questions on this front page, numbers 1 to 4, all relate to this diagram here. And just so you're aware, ladies and gentlemen, this is meant to be like a 3D picture. So this guy here is flat in the page. A triangle BCD is flat in the page. And then this one, ACD and ABC, are all kind of standing up. It's like the corners of a wall. And then so these are all 90 degrees. These three walls are meeting at 90. This angle here is 32. This angle here is 45. And all of the rest of the information can be found thusly. Okay? So I am going to, I'll give you what I recommend, and then you can do whatever you want. My recommendation is going to be we're going to go question number 1. We're going to go question number 3. Okay. We're going to do 5 and 6. 6 is good. 5 is really tricky. There's 2 triangles there. Because you've got an airplane that is, this is your airport, it's north and it's east. So you've got like this triangle here. But then you've got, this airplane is actually up. So you've got this other, what is beeping? Is it one of these phones? Someone's phone, something's beeping. So you've actually got something tricky here going on with question 5. I'll zoom in here so you can see a little bit better. You got this triangle that's flat on the ground, and then this dotted line actually goes up into the sky. So that one's good. 6 is good. I'm going to give you 7. And then the rest of it is as you are moved to practice more things. Okay? Give this a shot. Your trig quiz is going to be tomorrow. May the force be with y'all. I feel at this point, if you can solve whole triangles and you can solve these word problems, you can do everything that I've asked you to do in this chapter so far. So if you're comfortable with what's going on here in today's lesson, I'm not worried about you for this quiz tomorrow. If you're struggling with any part of this, though, there might be cause for concern, and I'm happy to assist you with whatever you might need. So you can use the rest of the class for whatever you feel like is important to you. After the quiz tomorrow, I'm going to give you guys your year-end reviews. Like covering everything that we've covered reviews. Everything.
Are we doing our finals on
Wednesday. 1 week from tomorrow is your final exam. Okay, there it is.